Welcome to this explainer. Today we're going to look at the physical world around us through a slightly different lens, the lens of mathematics. Because honestly, math isn't just a bunch of numbers on a page, it's the hidden language of our reality. By the end of our time together, you'll see everything, from the buildings you walk past to the actual food you eat, in an entirely different, highly structured way. Let's get right into it.
Okay, let's dive into this. Ever wonder how math sees an everyday ice cream cone? Or, a camping tent pitched out in the woods? We usually look at these things and just see a tasty treat or a place to crash for the night. But to a mathematician or even a 3D software engineer, these everyday objects are actually complex combinations of very basic, fundamental geometric shapes. Understanding how these basic shapes lock together to form our world, that is literally the first step in decoding the architecture of reality.
But before we start breaking down tents and ice cream cones, we have to establish one fundamental ground rule: the difference between 2D and 3D. A 2D shape is strictly two-dimensional. It's entirely flat, like a triangle drawn on a piece of paper. It has absolutely no depth. You can't put anything inside it. A 3D shape, however, is three-dimensional. It actually occupies physical space. It has volume. So that real ice cream cone in your hand, that's a 3D object because it physically takes up space in our world. To guide us today, we've got a clear roadmap. 1. Real-world shapes. 2. Changing views. 3. Shape anatomy. 4. Prisms versus pyramids. And 5. Euler's magic formula. Section 1. Real-world shapes. Math in the wild. Now, the secret here is that the objects we interact with daily are almost never single, perfect geometric shapes. They're combinations. Take that camping tent we mentioned earlier. It's often just a cone sitting directly on top of a cylinder. Or that ice cream. It's essentially a hemisphere, half a sphere, resting perfectly on top of a cone. Even a simple house is usually just a rectangular prism topped with a pyramid for a roof. Recognizing these combinations is the exact first step an architect takes when designing structures in the real world. In fact, if you've ever used modern 3D modeling software, this is exactly how it works. You build complex realities by mashing together these fundamental shapes. Section 2. Changing views, shifting perspective. Because architects and designers don't just look at a 3D object from one angle, they visualize it from multiple flat perspectives. Let's move to and see how this builds. Imagine you have an object resting on a table right in front of you. To map it out, you follow 3 steps. Step 1, you stand directly in front of it. That gives you your front view. Step 2, you physically walk to the side of the table. That's your side view. And step 3, imagine you are a drone hovering directly above the object looking straight down. That is your top view. Look at how radically an object changes depending entirely on where you stand. A simple brick might look like a long rectangle from the front, a short stubby rectangle from the side, and a large wide rectangle from the top. But look at the cup and saucer. From the front and side, you see the classic profile of a teacup. But if you hover above it for the top view, no way. You don't see a cylinder at all. You just see concentric circles, the rim of the cup, the liquid inside, and the edge of the saucer. It's the exact same object, but a totally different reality depending on your perspective. Section 3. Shape anatomy. The building blocks. Now it's time to open these shapes up and break down exactly what makes up these 3D objects. First up, we have faces. Think of a face as any flat, two-dimensional polygonal surface on the outside of a solid object. If you're holding a standard physical book or a basic box, the large, flat front cover is a face. The flat back cover is a face. Basically, if a surface is flat and you can place your hand entirely flat against it, you are touching a face. Next, we have edges. An edge is the straight line segment where 2 distinct faces meet and connect. Continuing with our book analogy, if the front cover is a flat face and the spine is another flat face, the hard crease where the cover folds into the spine is the edge. It's the border. It's the physical line where a 3D shape folds. And finally, we have vertices, which is the plural of vertex, by the way. These are the sharp corners. They're the pointy dots on a shape where 3 or more of those edges come crashing together. If you run your finger along the edges of a box, your finger will eventually hit a sharp point at the corner. That exact point is a vertex. Now, when you bring these 3 anatomical parts together, faces, edges, and vertices, you get what mathematicians call a polyhedron. A polyhedron is a 3D solid shape made entirely of flat polygons. And the VIP rule for the polyhedron club is that absolutely no curved surfaces are allowed. That means spheres, cones, and cylinders. Yeah, they are banned from this club because of their curves. Polyhedrons are all about flat faces, straight edges, and sharp vertices. Section 4. Prisms versus pyramids. Spotting the difference. Let's clear up a classic point of confusion between the two main types of polyhedrons. People constantly mix these up, but they are very different. A prism has two identical parallel bases. Think of a standard cardboard box. The bottom and the top are exactly the same. And importantly, all the sidewalls connecting those bases are flat rectangles. A pyramid, however, only has one single base at the bottom. So the crucial point is, because all the walls of a pyramid have to lean inward to meet at one single sharp top point, those side faces must be triangles. Prisms have rectangular side faces, pyramids have pointy, triangular side faces.
Section 5. Euler's magic formula, the secret code. This is a famous mathematician's tool that actually verifies physical reality itself.
We have arrived at the climax of our explainer. Named after a legendary mathematician, behold Euler's formula. F minus E plus V equals 2. For any given polyhedron in existence, if you take the number of faces, subtract the number of edges, and add the number of vertices, the result will always be exactly 2. And this brilliantly illustrates exactly how it works in practice. Let's take a standard cube, like a 6-sided die. A cube has 6 flat faces. If you count the lines, it has 12 edges. And if you count the sharp corners, it has 8 vertices. So let's plug that into our secret code. 6 faces minus 12 edges plus 8 vertices. 6 minus 12 is -6. -6 plus 8 equals exactly 2. The math adds up perfectly. It works every single time for every single polyhedron. I really want to emphasize that this isn't just some boring equation you memorize for a test. This is mathematics' ultimate verification tool. Think of it kind of like the OTP password you get on your phone when you're logging into your bank account. Euler's formula verifies reality. If you run the numbers for a 3D shape, faces minus edges plus vertices, and it does not equal 2, that shape is mathematically impossible. It physically cannot exist in our universe. Which brings us to our final provocative challenge. Imagine someone comes up to you and says they've discovered a brand new shape. They claim it has 10 faces, 20 edges, and 15 vertices. Will you let them trick you? Well, let's use our new superpower. 10 faces minus 20 edges is -10. -10 plus 15 vertices equals 5. Does 5 equal 2? No, it doesn't. The OTP failed. You can confidently look them in the eye and say, nice try, but that shape is mathematically impossible. You now have the power to verify the architecture of the universe itself, a rule that every video game physics engine, 3D printer, and modern architect must obey. Keep looking at the world through this lens, and I'll catch you on the next explainer.